Good morning, sir. This is Jay Prakash from ECB section. I am pursuing the BTech second year in VVIT University Nambur, and my seminar topic is basic logic gates. What are logic gates? Logic gates are fundamental building blocks of a digital electronic circuits. There are miniature electronic devices that perform basic logical operators on one or more binary inputs, producing a single binary output. The name logic gate is derived from the ability of such a device to make a decisions in the sense that it produces the output level when some combinations of input levels are present and the different output levels when other combinations of input levels are present. There are just three basic types of gates. There are AND gate, OR gate, and NOT gate. This fact that computers are able to perform very complex logical operations stems from the way these elementary gates are interconnected. The interconnections of the gate to perform a variety of logical operations is called a logic design. Digital font is essential for all modern digital electronics and widespread use for the found in computers, circuits and processors globally. AND gate. The AND gate has two or more inputs, only one but only one output. The output assumes the logic one states that the only one when each one of the inputs is at logic 1 state, the output assumes the logic 0 states even if one of its inputs is logic 0 state. The AND gate may therefore be defined as a device whose output is 1 if and only if all its inputs are ones. Hence, the AND gate is called as an all or nothing gate. The logic symbol and the truth table of a two-port AND gate are shown above, with the input variables to the AND gate represented by the A, B, C and so on. The Boolean expression for the output can be written as x is equal to A into B into C into and so on, which is read as x is equal to A and B and C and so on. Or like an OR gate, like an AND gate, an OR gate may have two or more inputs, but only one output. The output assumes the logic 1 state, even if one of its input is in the logic state. It output assumes the logic 0 state. Only when each one of the input in logic 0 state, an OR gate may therefore be defined as a device whose input is 1 even if one of its input is 1. Hence OR gate is called as an any or all gate. It is called be an inclusive OR gate because it includes the conditions both the inputs can be present. The logic symbol and truth table as the two input OR gate as shown above. The symbol of the OR operation is plus with the input variables to the OR represented by the ABC. The Boolean expression for the output can be written as x is equal to a plus b plus c and plus c. This is read as x is equal to a or b or c or and so on, or x is equal to a plus b plus c and so on. NOT gate. NOT gate is called as inverter. Has only one input of course only one output. It is a device whose output is always the complement of its input. This is the output of a non gate. Assume the logic 1 states when when its input is in the logic 0 state, and assume the logic 0 states when input in this in logic, the logic symbol and the truth table of an inverter are shown above. The symbol of the NOT operation is bar. When when the input variables of a to the NOT gate is represented by the A and the output variable by x, the expression of the output is x is equal to A bar. This is read as x is equal to A bar. A discrete NOT gate may be realized using a transistor. The IC 7404 contains 6 inverters. NAND gate. NAND gate means not AND. That is, the AND output is noted. So a NAND gate is the combination of the AND gate and a NOT gate. In fact, NAND is the concentration of the word not AND. The expression of the output of a NAND gate can be therefore it can be written x is equal to a b bar whole bar and so on, and it is read as x is equal to a into b into c and so on whole bar. The output is logic 0 level only when the each of the level reads input assumes the a logic 1 level. For any other combinations of the input, the output is the logic 1 level. The logic symbol and the truth table as shown in the above. NAND gate as is shown in the above. The logic symbol and the truth table of for 3 input NAND gate as shown in the above. NOR gate. NOR means not or, that is, the OR gate is noted. So a NOR gate is the combination of the OR gate and not a NOT gate. In fact, NOR is the concentration of the word not OR. The expression for the output of the NOR gate is x is equal to a plus b plus c plus so on whole bar, and it is read as x is equal to a plus b plus c and the b plus c plus c and whole bar. The output is logic 1 level only when each one of the input assumes the logic of a logic 0 level. For any combinations of inputs and the outputs is logic 0 level. The logic symbol and the truth table of a two input NOR gate as shown in the figure respectively. The logic symbol and the truth table for the 3 input NOR gate are shown in the above figure respectively. XOR gates. An XOR gate is the 2 inputs and 1 output logic circuits whose output assumes a logic 1 state when one and only one of its inputs assumes a logic 1 state under the condition when both the input assume the logic 0 state, or when the inputs assume the logic 1 state, the output assumes a logic 0 state. Since an XOR gate produces an output 1 only when the two inputs are not equal to, it is called an anti-coincident gate or inequality detector. The output of the XOR gate is the modulo sum of its two inputs. The name the exclusive OR is derived from the conditions, derived from the fact that the output is 1. Only when exclusive one of its inputs is a 1, it executes the condition when both our inputs are 1. The logical gates, the logical symbols and the truth table of the two input XOR gate as shown in the above figure. If in the input variables are represented by A and B, and the output variables by x. The expression for the output of the gate is written as x is equal to x is equal to a x or b is equal to a b bar plus a bar b. There are there are three or more variables XOR gate do not exist. When more than two variables are to be XORed, a number of two input XOR gates will be used. The XOR of a number of variables assumes a one state only when an odd number of inputs variables assume as one state. The Boolean expression whose values is equal to 1 when an odd number of its variables are equal to 1 is called an odd function. Ox XNOR gate exclusive OR. The definition and the symbol the XNOR get outputs 1 if its inputs are they both same. If inputs are differ, the output is 0. An XOR gate is the combination of an XOR gate and a NOT gate. The XOR gate is the two inputs and one output logic circuit whose output assumes as a one state only when both the inputs assume a 0 state or when both the inputs assume as a one state, the output assumes 0 state. When one of the input assumes 0 states and the other a one state, it is also called a coincident gate because its input assumes 0 state and other state one state. It is also called a coincident gate because its output is 1. Only when its inputs coincide, it can be used as equality detector because its output a 1 only when its inputs are equal. The logic symbol and the truth table of the two input XOR NOT gate as shown in the above figures. And if the input variables are presented by A and B and the output variables by X, the expression for the output gate is written as X is equal to A X nor B, that is equal to A B plus A bar B bar, that equal to A X nor B whole bar is equal to A B bar plus A bar B and whole bar. Conclusion. Powering the digital world. Number 1. Fundamental building blocks. The logic gates are the very essential. The logic gates are the very essence of digital electronics, enabling complex operators from the simply binary. Number 2. Core, they are indispensable components in the digital circuit, microprocessors, and all types of computing devices. Number 3. Ubiquitous application from basic calculators to sophisticated smartphones and the advanced computers, and their presence is a pervasive and driving our modern digital age. Mastering logic gates is the first crucial step towards understanding the digital systems. Thank you.